Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give more examples related to trigonometric ratios. So we're going to start off with having sine theta equals to 3 over 5 and theta is in the first quadrant. So next you have to go on and find this cosine of theta, tangent of theta, and so on. So we're going to start off by sketching the position of theta. So this is my x, my y. So theta is in the first quadrant. Therefore, theta will be somewhere here. This is my theta. And based on that, I can draw a right angle triangle. And you can see that because sine of theta is equal to 3 over 5, therefore the length here must have been 3. And over here, which is the hypotenuse, must be equals to 5. Now, this is unknown, so this is x. But according to Pythagoras theorem, we know that it says x squared plus 3 squared must be equal to 5 squared. And if you solve this, this is equal to 5 squared minus 3 squared, and this is just 25 minus 9, which is just 16. Therefore, x must have been a positive number and x must have been equals to 4. So yeah, I'm going to write down x here as equals to 4. Okay. So now we can go on and answer these questions. So I'm just going to write down, so sine of theta is equal to, since y is in the negative, is in the positive direction, and x here is also in the positive direction. Okay, the first quadrant here is related to having y positive and x positive. Therefore, our sine theta here will also be positive, which is 3 over 5. So cosine of theta will be adjacent over hypotenuse, 4 over 5. And tangent of theta will be 3 over 4. Next, cosecant of theta is the reciprocal of this one, which is 5 over 3. Secant of theta is also the reciprocal of this, which is 5 over 4. And finally, cotangent of theta is the reciprocal of this one, which is 4 over 3. Alright. That is quite simple. Now let's move on to the next example. Find the values of this when theta is in standard position and its terminal side passes through the point x negative 1 and y negative 3. So I'm going to sketch the position of theta. So this is x and this is y. Notice that x is in the negative direction, so this could be my negative 1. And next, this could have been my negative 3. So y is also in the negative direction. So this is my point here. And the terminal side passes through this point. So that means this is my theta. Okay, this is my theta. But we have learned in the previous video that if you want to find whatever values of interest related to theta, you can actually use the reference angle. So my reference angle is this one. So this is my reference angle. So we can just refer to this angle. And based on this, I can draw a right angle triangle. Okay, right angle triangle. And based on the points given here, I know that the length of this must have been 3, and the length for this one must have been equal to 1. And again, using the Pythagoras theorem, the length of hypotenuse must have been 2. Okay, Now let's answer the first question, which is what's the value of sine of theta? So sine of theta is sine of theta is opposite over hypotenuse, and this one has a because y is in the negative direction, therefore we have negative sec 3 over 2. Next, cosine of theta. Cosine is adjacent over hypotenuse. So again, this is a negative direction for x. So this is negative, x is in the negative direction. So here we have negative 1 over 2. Okay, the next one is tangent of theta. Tangent of theta is opposite over adjacent. So here is y is in the negative direction, so we have negative sec 3, and x is also in the negative direction, which is negative 1. Therefore the answer here will be positive sec 3. Next, we can continue and get the answer for cosecant of theta. Cosecant of theta is just negative 2 over sec 3. This is the reciprocal of sine theta. Next, we will have secant of theta. So secant of theta is just secant of theta is just negative 2, and finally cotangent of theta is 1 over sec 3. Alright, thank you very much for watching. See you in the next video.